we're in a stronger zone of geochemical signatures here, right? So the first drill hole at the hat was right here, and then hole number 2, hole number 3, hole number 4, hole number 5. Now these first 5 holes, they weren't drilled very deep, but the results from the first 5 holes were not what they were going down here to the Lisle Zone. So was something missed in these initial 5 holes, or were they not drilled at the right angle, or did they just kind of hit the gaps that you often see in these porphyry systems? Like what happened in those first few holes?
Yeah, that's a very good question, John. I can see I think it's all about the geometry of mineralization in the porphyry system. When I came back and I reconstruct all the geochemistry and the structures, and I end up with this very, very strong linear northwest-southeast trend. And you can see the drill holes are actually being drilled kind of sub-parallel to that trend. So they're not actually cutting across the trend of mineralization. And plus, obviously, they're all pretty shallow holes, and they're just scratching, the topmost part of the system, which is normally overprinted by late-stage sericite clay chloride alteration. But yeah, I think to me that was the main factor, that the geometry and the angle and the azimuth of the drill holes should have been across the trend. And we're taking that model and applying to the rest of the property, because we do have a strong correlation of these linear magnetic anomalies with the geochem anomalies, as well as these dikes that are oriented in northwest-southeast orientation. So geologically, you have to go across the trend. And as you can see, these are it's a package of stacking anomalies on one another. So you would kind of go in and out of the system multiple times. So you will have gaps in between for sure, but it is the frequency of these high-grade zones that gives you a deposit.